You know that incredible scene in the movie Interstellar? The one where the astronauts visit a planet and for every single hour they spend there, 7 years rocket by back home on Earth? It feels like pure science fiction, right? Well, the secret behind it is actually one of the most amazing truths about our own universe. This is the scene that just sticks with you, isn't it? The crew lands on that water planet, just a few hours of total chaos go by, and when they get back to their ship, the person they left behind has aged decades. It just seems impossible. But what if I told you it's not just possible, it's real?
That's right. The key to this whole mind-bending mystery is a very real concept, and it forces us to completely rethink the fabric of the cosmos itself. And that means we gotta start with the very nature of space and time.
Okay, so first things first, we have to kind of throw out our everyday ideas about how space and time work, because our gut feeling on this, it's actually wrong. You see, for centuries, we all saw the universe through Isaac Newton's eyes. Space was just this rigid, unchanging box that everything happened in. And time? Time was like a giant cosmic clock, ticking away at the exact same rate for every single person everywhere. But then Einstein came along and proposed something so radical. He said space and time aren't separate things at all. They're actually woven together into this single, flexible, four-dimensional fabric.
And he gave it a name: space-time. And this, right here, this is where everything changes. Because if space can be stretched and bent, and time is part of that exact same fabric, well, that means time itself can be stretched and bent too. It's not a universal clock anymore.
So if space and time are part of this bendy fabric, you've got to ask, what's doing the bending? This brings us to a totally revolutionary way of understanding a force we feel every single second of our lives: gravity. We usually think of gravity as some kind of invisible rope, pulling things toward each other. But according to Einstein, that's not what's happening at all. The truth is way, way cooler.
Gravity isn't a force acting inside space-time. Gravity is the shape of space-time.
Okay, I know. What does that even mean? Let's try an analogy. Picture space-time as a huge, stretched-out trampoline. Now, if you take a really heavy object, like a bowling ball, and you set it right in the middle, what happens? Of course, it creates a dip, a big curve in the fabric. In the real universe, massive things like planets and stars do the exact same thing to space-time. Now, what if you roll a little marble nearby? Is it being pulled by the bowling ball? No, it's just following the curve in the trampoline that the bowling ball created. That path it takes, that's gravity. The Earth isn't pulling you down right now, it's bending the space-time around you, and you're simply moving along that curve. All right, so gravity is just warped space-time. But how in the world does that explain how 1 hour can equal 7 years? This is where it all clicks together and takes us right back to Interstellar. It's actually pretty straightforward. The more massive something is, the deeper the curve it carves into space-time. A planet like Earth makes a little dimple. A star makes a bigger one. But a supermassive black hole like Gargantua in the movie, it creates this incredibly deep, steep gravity well. And since time is part of that same fabric, the deeper you go into that well, the slower time itself actually flows. 7. That was the number, wasn't it? For every single hour those astronauts spent down near that black hole, 7 long years passed for everybody else. Just let that sink in for a second. For Cooper, who's deep inside Gargantua's powerful gravity well, only 1 hour goes by. But for his daughter, Murph, way back on Earth where gravity is much weaker, those exact same moments stretch out to become 7 years. This isn't just some clever movie trick. It's a real, proven phenomenon called gravitational time dilation. So this idea isn't just some weird thing that happens near distant black holes. It has really profound implications for how we understand reality itself, right here and right now. So what does all this mean for us? It means there is no single universal clock. Time is relative. Your personal experience of how fast time passes depends on how fast you're moving and the strength of the gravity around you. In fact, the GPS satellites orbiting our planet have to constantly correct their own clocks. Why? Because time literally runs a tiny bit faster for them up in orbit than it does for us down here on the ground. The effect is totally real. And that leads to a truly staggering thought. If two people can experience time passing at completely different rates, then the whole idea of a single, simultaneous now that applies to everyone everywhere, it just falls apart. My now might not be your now. It's almost certainly not the same now as for someone in another galaxy. And that's really the ultimate takeaway here. Physics forces us to bump right up against philosophy. If time isn't this fixed, solid foundation we thought it was, but instead it's this flexible thing that changes depending on where you are and how you move, what does that say about the reality we all think we share?